Get ready to embark on an out-of-this-world adventure as we take you on a journey to explore the incredible feat of engineering that is the International Space Station, ISS. From its conception to its ongoing operation, we'll dive deep into the fascinating story of how the ISS was built and how it operates, with the help of some cutting-edge computer tomography angiography (CTA) technology that will give you an unprecedented look at the inner workings of this amazing space laboratory. So buckle up and prepare for liftoff as we take you on a ride through the history and science of the International Space Station. The International Space Station, ISS, is a multi-nation construction project that is the largest single structure humans ever put into space. Its main construction was completed between 1998 and 2011, although the station continually evolves to include new missions and experiments. It has been continuously occupied since November 2, 2000. The ISS is not owned by one single nation and is a cooperative program between Europe, the United States, Russia, Canada, and Japan, according to the European Space Agency, ESA. About ISS. The International Space Station weighs almost 400 tons and covers an area as big as a football pitch. It would have been impossible to build a space station on Earth and then launch it into space in one go. There is no rocket big enough or powerful enough. To get around this problem, the space station was taken into space piece by piece and gradually built in orbit, approximately 400 kilometers above the Earth's surface. This assembly required more than 40 missions. The International Space Station costs about $3 billion per year for NASA to operate, roughly a third of the human spaceflight budget. The ISS includes contributions from 15 nations. NASA, United States, Roscosmos, Russia, and the European Space Agency are the major partners of the space station and contribute most of the funding. The other partners are the Japanese Aerospace Exploration Agency and the Canadian Space Agency. Through a private company called Axim Space, private astronauts are starting to work on the orbiting complex from time to time. Additionally, astronauts from other nations, such as the United Arab Emirates, do fly occasionally to the ISS. History and how it was built. Just as the oceans opened up a new world for clipper ships and Yankee traders, space holds enormous potential for commerce today. The International Space Station, ISS, took 10 years and more than 30 missions to assemble. It is the result of unprecedented scientific and engineering collaboration among 5 space agencies representing 15 countries. The space station is approximately the size of a football field, a 460-ton, permanently crewed platform orbiting 250 miles above Earth. It is about 4 times as large as the Russian space station Mir and 5 times as large as the U.S. Skylab. The idea of a space station was once science fiction, existing only in the imagination until it became clear in the 1940s that the construction of such a structure might be attainable by our nation. As the space age began in the 1950s, designs of spaceplanes and stations dominated popular media. The first rudimentary station was created in 1969 by the laking of 2 Russian Soyuz vehicles in space, followed by other stations and developments in space technology, until construction began on the ISS in 1998, aided by the first reusable spacecraft ever developed, the American shuttles. Since the International Space Station is a multinational collaborative project, the components for in-orbit assembly were manufactured in various countries around the world. Beginning in the mid-1990s, the U.S. components Destiny, Unity, the Integrated Truss Structure, and the solar arrays were fabricated at the Marshall Space Flight Center and the Mickout Assembly Facility. These modules were delivered to the Operations and Checkout Building and the Space Station Processing Facility, SSPF, for final assembly and processing for launch. The Russian modules, including Zarya and Zvezda, were manufactured at the Khrunichev State Research and Production Space Center in Moscow. Zvezda was initially manufactured in 1985 as a component for Mir-2, but was never launched and instead became the ISS service module. The European Space Agency, ESA, Columbus module was manufactured at the EADS Astrium Space Transportation Facilities in Bremen, Germany, along with many other contractors throughout Europe. The other ESA-built modules, Harmony, Tranquility, the Leonardo MPLM, and the Cupola, were initially manufactured at the Thales Alenia Space Factory in Turin, Italy. The structural steel hulls of the modules were transported by aircraft to the Kennedy Space Center SSPF for launch processing. Operations. The IS consists of several modules connected by pressurized tunnels, which provide living quarters, workspaces, and storage areas for the crew. The modules are powered by a complex network of solar panels, batteries, and fuel cells, which generate and store electricity for the station's systems and equipment. The ISS also has a sophisticated communication and navigation system, which allows the crew to communicate with mission control centers on Earth and to monitor the station's orbit and position in space. The IS operates in a microgravity environment, which poses unique challenges for the crew and their equipment. The crew members must exercise daily to maintain their health and prevent muscle and bone loss, and all objects and equipment must be secured to prevent them from floating away. The ISS also has a complex environmental control system, which regulates temperature, humidity, and air quality inside the station, and recycles water and air to minimize waste and conserve resources. The ISS is serviced by a fleet of spacecraft, including the Russian Soyuz and Progress vehicles, and the American SpaceX Dragon and Northrop Grumman Cygnus. These spacecraft are used to transport crew members, supplies, and scientific experiments to and from the station, and to perform maintenance and repair tasks. The crew members also perform spacewalks to install and repair equipment outside the station, using specialized spacesuits and tools. It maintains an orbit with an average altitude of 400 kilometers, 250 miles, by means of reboost maneuvers using the engines of the Zvezda service module or visiting spacecraft. The ISS circles the Earth in roughly 93 minutes, completing 15.5 orbits per day. Purpose of ISS. The mission of the International Space Station is to enable long-term exploration of space and provide benefits to people on Earth. With 6 state-of-the-art laboratories, the space station will be the premier research facility in space, 4 times larger and more capable than any previous space station. It is hoped that it will allow for advancements in medicine, technology, and science. For example, studies in micro and hypergravity will help researchers better understand its effects on humans and offer insight into how the human body works. Growing protein crystals in a space environment can help scientists create better treatments for numerous diseases that currently have no cure. In addition, the laboratories on the space station will allow for innovative space research projects to improve our understanding of the Earth's environment and the universe in which we live. In conclusion, the International Space Station is a marvel of human engineering and international cooperation. From the initial planning and construction stages to its ongoing operation and scientific research, the ISS represents the best of humanity's creativity, perseverance, and determination. The IS has expanded our understanding of the universe and has inspired generations of scientists, engineers, and explorers to continue pushing the boundaries of space exploration. If you enjoyed the video, kindly subscribe to our channel so you won't miss out on our videos.